we've got, I don't know if I don't want to name any names, but there are implementation of SNMP v3 which are really, really buggy. And it's not our fault, it's the switch's fault. And so sometimes, you know, we face problems and we need to pull in other modules and stuff. And it's a love-hate relationship with SNMP v3. I really prefer when a customer has a management VLAN which is guaranteed to be isolated. And so I'm telling them, you know what, SNMP v2 is fine by me if you're sure that no one can sniff on your management VLAN. But again, it's all arguable. So the PacketFence Zen is the zero-effort NAC, which is a VMware appliance which we have version for the desktop suite and also the ESX stuff. So it's pre-installed, pre-configured, and people can really try PacketFence quickly with a VM instance. So just wanted to let that out. He's glad. I'm glad that you're glad. Okay, so open source for the win. What has been great for with doing open source for us is the vendor independence. A lot of the network access our competitors, if you want, they really glue into a vendor, or they do not, and then do ARP poisoning or other inline techniques, which are, in my opinion, less secure. And so, because of being open source, we kind of, you know, poke at the firmware and try to make it work. And when one wants a device implemented, we work on it. And a lot of the, let's say, mostly universities, they actually develop their own module and they send it to us. And then we support new hardware, and that's just been great. The proprietary pricing is questionable. There is per IP, per concurrent connection, per AP access point, per switch license fees. So it's really kind of odd, and for a lot of people migrating over to PacketFence, they tell me, like, we pay so much for our NAC solution, it just doesn't make any sense. And it's because they charge per IP, and people are using wireless, and every device that you have like 5 of them on yourself, and you just cost them 5 licenses because they all wanted to hook on the network. And so sometimes they really like, we need to move away from the proprietary stuff. Also because we can stay focused and we build on top of Apache, Bind, DHCP, NetSNMP, FreeRadius, Snort, IP tables, Nessus, 70+ CPAN modules that we pull in when you install PacketFence. So like, we're really into reuse, I guess. We use Linux, and it's been really great. So this is also an advantage because the stack is familiar. So you guys all know the tools, and when you really need to tweak the things, you can do it yourself. And when you need to troubleshoot, it's not dark arcane magic that you cannot understand or you need to call support for. It's stuff that you actually can see and that you can Google on Google. So it's great because, okay, I have this FreeRadius problem, I Google it, and then, oh, everyone has a similar or a twist different problem, and you can help troubleshoot yourself by doing that, which is not something we can say of the proprietary offerings. And so it's been also good. Security is not necessarily solely based on obscurity, sorry. So what I mean by that is that this is network access control. There are some things that we kind of lift the carpet and put the dust under the carpet because we are doing questionable things, because we want, you know, the customer to be able to deploy easily, and, you know, a NAC is better than no NAC, so we still need to have them. It all boils down to user friendliness versus security, and you guys all know about that. So other solutions can be all about obscurity, but we, since it's open source, people can look at it and say, hey, you guys are doing like funky stuff over there, and maybe you should not do that. And so it's an advantage because you can look at it, poke at it, and find problems. So what I've been learned and what have been we doing bad and doing good for the last 2 years, so let's go. Most NACs are easy to bypass. This is something I learned while working at Inverse because of network administration friendliness. So per port exceptions for printers, voice over IP, uplinks, you find them, you can leverage them. CDP is being enabled on access port, which is, in my opinion, a problem. Real DNS is exposed, so if your NAC solution is based on offering the internet DNS, there are a lot of tools to be able to tunnel TCP into DNS, so you can tunnel out. And because there is no authentication built into layer 2 or layer 3, if you're not doing 802.1x, everything can be hacked or spoofed. So you can change your IP address, you can change your MAC address, you can change your DHCP client to be able to spoof the fingerprints I was talking about earlier. You can spoof your user agent, and user agent spoofing has been known to get you out of Cisco's NAC profiler. Anyway, they see if it's an iPod or iPhone or iPad user agent, then they let you through because they don't have any agents for this OS. And so because of that, again, it's because there's no authentication, and you can spoof this stuff client side, and there's the trust, which is fake, then is easy to bypass. And so again, coming to MAC address spoofing, printers don't have browsers, so they will often be pre-registered into the NAC devices. And so printer is so easy to find the MAC address on a printer. You go there, do your physical pen test, you pop the printer on the side, you look at the MAC address, you put it on your Backtrack 5 client, and then boom, you're all out in the printer VLAN, and you can start scanning the print servers, which are Windows, which are not patched, etc. So another thing I learned is that you can bypass 802.1x, but there's a talk actually right after this, which is focused only on that, a 2-hour talk on how to bypass NAC 802.1x. But let me still tell you what's the technique. So you put a hub between the victim and the switch. The goal is to prevent the port from going down. So if there is no link down, then the stack is not reset, because it's a port-based network access control, and once the access has been granted, there is no continuous monitoring of what you have been doing with the access. So you wait for the victim to successfully authenticate, because you put a hub in between. You spoof your MAC address with the victim's MAC, and then you plug into the hub, and bam, you bypassed 802.1x completely. This was I discovered this by kind of a mistake when I was working on 802.1x capable phones, and I kind of couldn't believe it, and I Googled it, and then I found on Wikipedia and on Microsoft there is an article from 2005 talking about this problem. But now the bad thing is that they're doing appliances like the Pony Express, which is doing 802.1x bypass. So it's really interesting to see that it's gaining traction after all that time. So the attack scenario is you have two things you can do. You keep the legitimate client connected, which is bad because you'll have duplicated MAC addresses on the same segment, but which is good because the client can re-authenticate if the switch asks to. Or you replace the legitimate client, which is bad because you won't pass a re-authentication request because you're not able to provide a strong authentication. But what is good about it is that you will not have network problems because there are no duplicated MAC on the segment. It works, and see the A Bridge Too Far talk by Skip, which is after this talk in track 1. And I'm pretty sure that because he's doing bridging, he'll be able to circumvent the problem I'm mentioning here, the attack scenario, because he'll be able to firewall in between, let the heap over LAN go through the client, but still intercept the good stuff that he's want to do in the man in the middle. Getting into 802.1x is tricky business. I'll just skip that. It's buggy. The support varies and stuff. Another thing, the 802.1x wired on Mac OS X is buggy. I haven't tried to reproduce it on in Lion, but it's definitely buggy. We opened a ticket with Apple, and they said send us a ton of logging, and we did, and we never hear back from them. But we'll revalidate again on 10.7. But still, the point is, it's just that we're always finding problems in every, pieces where we need to interact with, and it's not an easy game to be a network access control software. What I learned also is network vendor fragmentation. So VLAN assignment through SNMP is done in like I don't know, maybe 25 different ways. They are port lists. They are really straight one assignment. So a lot of different weird stuff that you can see. Port security is named differently, implemented differently. SNMP access is inconsistent. If you go into the radius-based enforcement, then wired MAC authentication has many, many names. I think I have a few here. Where is it? So Cisco calls it MAC authentication bypass, or MAB. HP calls it MAC-based authentication. Nortel calls it NEAP, which is no EAP. Extreme Networks calls it net login. Juniper calls it MAC radius. So there's a lot of different stuff going on in that space, and it's not making anything easy for us. There are gray areas in .1x where you don't really have guarantees about what will go with the DHCP on the client, and thus the problems probably with the Mac OS X. The radius change of authorization is not supported everywhere, which makes it a little bit harder too. So really hard, but the situation on the wireless side is better. I guess they learned from the wired side of things, and they avoided a lot of mistakes. So MAC authentication and 802.1x wireless is really great, and we've been implementing really more easily the APs and the controller. Usually, I don't know, like one day to figure out how it works and make it work, and another day to document for our network administration guide, and make additional tests to make sure that it will scale and everything. So 2 days, and we support a new controller brand, so which is pretty good. Learn network vendors firmware quality. So there are so many regressions, and we like get client, they update an iOS. Did I say iOS? They upgrade a switch firmware, and then boom, something that used to work before stops working now. And so it's really, really painful. Weird coincidences. I've saw the same exact bug implemented in like 4 different brands, and I couldn't believe it. I was like, it's the same bug, and it's an obscure bug. And so you see that there is probably a lot of, people buying code out of other vendors and stuff, and a lot of reuse of the same code, which unfortunately, I guess, is handled very differently because the bugs are fixed in one vendor but not the other one, but it's obviously the same bug. Also, something that happened with us is, oh, I think there's a bug in there, and the vendor says, oh, right, it doesn't work using the command line interface, but it does work in the web GUI. But who manages hundreds of devices using a web GUI, aside from controllers, which do a pretty good job, but for switches, come on, this is really odd. And scale issues, I just wanted to hint on an issue I faced where the people were handling in the SNMP, they were handling the MAC addresses saw on the layer 2 in the same table as the MAC addresses secured on ports. So when you want to list the secure MAC address on the switch, if the layer 2 network is really large, then you start to SNMP walk tens of thousands of devices, and it makes the whole thing completely slower. So we often face problems like that, and that we just don't know what to do with that. And then we rant on the network vendor, and they say, hey, come on, it's not us. It's been working fine for most people. But then you ask them, do you have NAC implemented with one of the NAC providers? And they say, no, what's NAC? So it's a problem. I know some people aren't going to agree with this, but all vendors hold tight on their issue trackers. I'm talking network vendors again. Most, they hold tight on their firmware. So we have... the customer pays us to implement NAC on their switch, and we are having a hard time downloading their firmware. This is not normal. Like, we need to escalate and send a lot of email. Some of them even hold tight on their documentation. So we got a physical switch that they sent us, but we are having a hard time download a PDF to configure the said switch. It's really, really a problem.